Hi, everybody. Welcome. In this video, we are going to have a little bit of fun exploring an introduction to random variables using a data set of songs, kind of the most played songs on Spotify from songs from 2000 to 2019. And so if you want to play around with this Colab notebook, I put a link to this notebook in the description of this video. And I also put a link to kind of the full textbook from which this comes from. Okay, so the first thing we want to do is load this data set into our Colab session. And so this data is stored in a file which is called Spotify hits.csv, which is in GitHub. So it's in a cloud that's accessible for all of us. And so the first thing we want to do is take this file that's living into a cloud and download it into our session. So I'm going to run this first code cell, and now this stored all of that data into a data frame that I can access in this notebook called hits, H-I-T-S. So I don't see any output because this just created a data frame. And some of the variables here are not being stored correctly. So in particular, all of the variables that involve words are being stored as characters, as opposed to categorical data should be stored as factors. So this first code cell below is going to do several things. It's going to convert the artist variable to a categorical variable using the factor command. We're going to convert song to a categorical variable. We're going to convert the genre to a categorical variable. And this data frame, it has all sorts of variables in it. A lot of them we're not going to need for this example. So we're just going to pull off a couple of variables from the full data set. So I'm only going to pull off the artist variable, the song variable, the tempo variable, and the genre variable. I'm going to drop all the other variables. So we're going to store just those 4 variables in our data frame hits. And this last command, head hits, is going to display the first 6 rows of the resulting data frame. So running this, I can see that the first observation in the data set is the Britney Spears song, Oops, I Did It Again. The tempo is 95.053 beats per minute. And this is being categorized in the pop genre. Blink 182 is another song, and that's being categorized in 2 different genres, rock and pop, and so on. So this is what the data looks like. It's a whole list of songs, and we know the artist, the song, the tempo, and the genre of that song. Okay, so let's kind of explore this a little bit. Let's think about, well, how many observations are there in total in this data set? Maybe some questions that might be worth looking at are like, which artist had the most hits over that 19 years or that 20-year span? What's the mean tempo of all of the songs in this data set? And how could we create some visualizations to display the distribution of tempos, and which genre occurs most frequently in this data set? So one way that we can take a look at the data is using the structure command. So that's this str. We want to look at the structure of the hits data frame. And this tells me that I've got 2,000 observations. So there are 2,000 songs in this data set. We've kept only 4 variables from the original data set, which were artist, song, tempo, and genre. Artist, song, and genre, we converted to factors. So these are being treated as categorical variables, and tempo is being stored as a decimal, which we can see over here, some of the initial values for the tempo. So that answers kind of the first question. If we want to think about, well, which artist had the most hits, what genre occurs most frequently, we can run this summary command over here. So if I run summary on hits, I get answers to both of those questions. So because we stored artist as a categorical variable, when I ask it to summarize the artist variable, it's going to give me the counts of how many songs each artist has in this data set. And so here we can see that Rihanna, she had the most songs in this data set. She had 25 songs that were you know, out of the top 2,000 hits over that period from 2000 to 2019. And another question was asking, well, which genre occurs most frequently? And so the pop genre is the genre that occurs most frequently. There are 428 out of the 2,000 songs were pop. So that answers how many observations are in the data set, 2,000. Rihanna had the most hits. The pop genre occurs most frequently. So now let's take a look at the tempo variable. So this is the only numeric variable that we've kept in our data frame hits. And if I want to calculate the mean tempo, then I would use the mean command, and I want to calculate the mean of tempo. And that's going to tell me the mean tempo is like 120 some odd beats per minute. And I could also have just gotten that from the summary command. So the summary command that's super useful. We could have answered almost all of the questions just by looking at the output of summary. But the summary command does not provide a visual kind of this summary of the tempo. So if I want to create some nice ways of visualizing the distribution of all tempos of all of the songs in this data set, two of the displays that we've looked at, two of the graph types, if we're working with quantitative data, which tempo is, we can create a histogram using the hist function. And this gives me a distribution of the tempos, just kind of without cleaning up any of the titles or anything like that. We can get a sense of what the distribution of all tempos look like. And we can see that this data has a slight skew to the right. We have a slight tail over here on the right side. Another reasonable display would be something like a box plot. So if I want to create a box plot of this, I would just do box plot hits tempo. And here we can see the resulting box plot, and we can see all these outliers over here, which also indicate that there's a slight skew to the right with the tempo distribution. And these are probably the two most common ways that we might summarize this data. We'll look at a density distribution later on, but for now, these are two very reasonable displays. You might think that the plot command would give us a good summary here, but when we're working with numeric variable, kind of the default output that we get from plot is an index plot, which is not particularly helpful. So I wouldn't want to use the plot command, but box plot and histograms, these are two reasonable ways of displaying the distribution of tempos. Okay, so I think that answers the first question that we have here. I summarized all of those answers down below. Okay, so let's say I'm going to create a playlist at random from this data set hits. I'm going to create a 5-song playlist. Let's kind of see how we could do that in R. So the first thing that I'm going to do is just pick some of the rows at random, and I'm going to store this in index. So over here, I'm going to run the command sample n row hits, size equals 5, replace equals true. So again, this is going to pick 5 rows at random from this data set hits. I'm going to choose 5 of them. And each time I pick a row, I'm going to put it back into the bag, and I'm going to be able to pick it again. So that's what the replace equals true means. Each time I pick a song, I'm going to put it back in. And it's possible that I could get a playlist of 5 of the same exact songs. So index is going to have the rows, the 5 rows that I'm going to choose for my playlist. And now I'm going to go in, hits index is going to pull off just those 5 rows, just those 5 songs that I've chosen for my playlist, and store it into a much smaller data frame called playlist. And now the head command is going to print the first 5 rows, it's going to print all of the rows in my playlist. And so in this case, I've got a playlist of 5 songs. And you can see kind of the distribution of those songs here. And in this playlist, I've got 3 songs that were pop songs alone, and I have 2 other songs that were not classified as just a pop song. And if you're running this, you might see that you have different output, and that's because this is selecting a playlist at random. So I could run this again, and now I've got a different playlist of 5 different songs. So every time you run this code cell, it's equivalent to like generating a different random playlist of 5 songs. So what I want to take a look at is, let's consider all of these different playlists of 5 songs that we could get. And what I want to count up is how many songs in that playlist are categorized under the genre pop. So for the playlist I have up top, I would say that 2 out of the 5 songs in my playlist are classified as just pop songs. And I want to be careful here that we're not counting this Drake song as a pop song because it's also classified in other genres. So what I would like to do is create a playlist of 5 songs and then think about, out of those 5 songs, how many of them are classified in the genre of pop and only pop and no other genre. So that's where random variables can come in. So again, here what we want to take a look at is, well, how likely is it that we get a playlist of 5 songs that has a certain number of pop songs in the playlist? So let's kind of define what a random variable is, and then we can see how it applies in this context. So a random variable is a function, so that might be confusing in itself. It's not random and it's not a variable. It's a function that's mapping each outcome, lowercase omega, from a sample space that we denote with the capital omega to a real number. And we typically denote random variables with capital, like Latin letters. So usually capital X is like a generic random variable. So what we're doing is we're applying this random variable, which is a function. We're applying this function to each outcome in our sample space. So in our example of this 5-song playlist, the sample space here would be all possible 5-song playlists that you can get. And since we're picking at random, with replacement, it's possible that you could get a playlist with 5 of the same songs. So our sample space has a total of 2,000 to the 5th power outcomes in our sample space. Each outcome corresponds to a different playlist. And this 2,000 to the 5th power, that comes from the fact that for the first song, we have a choice of 2,000 songs. For the second song in our playlist, we again have a choice out of 2,000 songs. And for each song that we pick out of the 5 songs, each time we have a choice of 2,000 songs in general. So altogether, that's the 2,000 to the 5th power, which is a huge number of things in our sample space. But for any one playlist that we have, we can count how many songs in that playlist are pop songs. So for example, one possible outcome that we could get, so one possible omega would be a playlist that has 1 hip hop song, 1 country song, 1 pop song, 1 rock song, and 1 pop song. And now our random variable that we're going to define here, x, is we apply this function to each outcome. And here our function is count how many songs in our playlist are pop songs. So we take this outcome, which consists of a bunch of genres, it's not numeric, and we're going to count how many songs in that playlist are pop songs, and now the output is going to be a number. For this particular outcome, we have 2 out of 5 pop songs. So when I apply random variable x to this outcome, I get 2. And the possible values that I could get out of x, so if I take a playlist of 5 songs, it's possible that I get no pop songs, 1 pop song, 2 pop songs, 3 pop songs, 4 pop songs, or all 5 of the songs in the playlist are pop. So we would consider this a discrete random variable, since the possible values of x are a discrete set of integers here. So 0, 1, 2, 3, 4, and 5. It's not a continuous set of values. I can't get 0.54 pop songs, right? So we're counting the number of pop songs, which is going to result in output, which is going to be an integer. So this is an example of a discrete random variable. So again, here our random variable X, we're applying this to the sample space of all possible 5-song playlists. And this random variable X is going to take a playlist of 5 songs and count out of those 5 songs how many of them are pop songs. Okay, so in this case, again, there were some songs that are being placed into multiple genres. So like this Blink-182 song is being classified as a pop and a rock genre. So we're not going to consider that a pop song. We only want to count the number of songs that are put into one genre of pop. So it might be good to know, okay, we've got a total of 2,000 songs in this data set hits, in the full data set that we're picking our playlist from. So let's count up out of those 2,000 songs, how many of them were pop songs. And that's what this sum command is doing down here. This is going to go into the genre variable and count up how many of the genres are equal to pop and only pop. And we saw this earlier in the summary output, but this is the most common genre, and there were 428 pop songs out of the 2,000. So that means out of all of the songs in our library here, which is hits, 21.4% of them, the 428 out of 2,000, are pop songs. So now we can answer questions like, okay, if we are picking from a library of music where 21.4% of the songs are classified solely in the pop genre, how likely is it, what's the probability that we would pick a playlist that would have no pop songs? So that's what we mean here. What's the probability that random variable X is going to equal 0, that we pick a playlist of 5 songs with no pop songs? And equivalently, we can ask, or similarly, we could ask, what's the probability of picking a playlist, an outcome, where all 5 songs are pop songs? And here, when we're picking our playlist, again, just to be really clear, we're picking with replacement. So each time I pick a song, I replace it, and it's possible that I pick it again. So we could possibly get a playlist of the same song 5 times. Okay, so each time I pick a song from this playlist, right, we've got a 21.4% chance that it is a pop song. So if I want to calculate the probability that X is exactly equal to 0, that I have not picked any pop songs, well, the first song that I pick, the probability that it is not a pop song would be 1 minus 0.214. So that's like the 78.6% chance of picking a non-pop song. Okay, and so here, again, we're considering songs that might be put into multiple genres as not a pop-only song. So the first song that I pick, this is the odds that it's not a pop song. The second song that I pick, it also has the same odds of not being a pop song. The third song, the fourth song, and the fifth song. So in this case, I'm going to take 1 minus 0.214, multiply it 5 times, or I could raise it to the 5th power, and that's going to tell me the probability of getting no pop songs in our playlist. Similarly here, if I wanted to calculate what's the probability of picking all 5 pop songs, well, the first song that I pick has a 21.4% chance of being a pop song. The second song that I pick has the same odds of being a pop song. And each time I pick a song, the odds that it's a pop-only song is 21.4%. So I can calculate this probability by taking 0.214, multiplying that 5 times, or raising that to the 5th power. So I'm going to run code to calculate those, and we can interpret the output here. So this is the result of this calculation, this first calculation. So here what I can see is that there's like a 30% chance of picking a playlist of 5 songs where none of them are classified as only pop. And we can see that there is a really small chance, let me do the decimal correctly here, like a 0.04% chance of picking a playlist where all 5 songs are pop-only songs. So here we can calculate some probabilities that random variable X takes on certain values, that we get a playlist that has a certain number of pop songs on our playlist. Okay, so I've summarized that down below here. So that's a wrap for this little introduction into random variables. We'll talk about these ideas further, and we'll explore continuous random variables together in class, but hopefully you've got a little introduction to the data set that we're going to be working with, and we have an idea of what a random variable is, and we'll build off of that in class. Thanks, everyone.